In this video, we're going to talk about weighted means. Now, as students, you actually have a lot of great examples of weighted means kind of built into being a student. So let's consider this first example. Suppose your grade in your math class is simply an average of three things: your test score, your homework average, and your grade on a project. Then each of these components have the same weight in terms of your grade. So if we let a box indicate the size, indicate a component's weight, then the picture might look like this. Size of the box indicate a component's weight. There we go. There's the word size. Okay, so meaning since we're saying that all the components have equal weight, they all share exact same size in terms of your grade. Okay, but suppose instead that your tests make up 50% of your grade and your homework and project are each worth 25%. Then the components are weighted differently. So in our model, the size of the boxes would change. Let's model this. Okay, so instead, if tests are supposed to make up 50% of your grade or half of your grade, then we want the test box to be twice as big as the other two. So here, let me go ahead and redraw that. So here's my test box. So there's the test average. And then the homework box, you want it to be half as big, and the project box also same size as the homework. And then those two combined together would be, wow, that's not how you spell homework, spell homework, but here we'll do it like this: homework. And I'm going to abbreviate average, AVG, and then project average. And there we go. So we would have this kind of breakdown where the test is like twice as much. It's taking up 50% of the whole grade. And then the homework is another 25 and the project's number 25. So the tests would weight more than the other two in that scenario. So use the weights given in that question. Oops, that shouldn't say question 5. That should actually say question 1. I'll fix that before this video gets posted. Let's say you get a score of 71 out of 100 on your test, a score of 96 out of 100 on your homework, and a score of 88 out of 100 on your project. Let's organize the information in the table below. So the grade you earned then is 71 out of 100. So 71 for tests, 96 for the homework, and 88 on the project. And then this last column, they're asking us to multiply the weight that they're given to each times your actual grade. So if you take the weight, which they're writing as a percent, as 0.5, and take 0.5 times 0.7. So 0.5 times I'm sorry, not 0.7, but 71. That would give me 35.5. Okay. So for homework, since it's 25%, let me go ahead and write that as a decimal, 0.25. So I'm going to take 0.25 here. I'm going to drop the 0 just to fit it in, times 96, and that's going to equal 24. And then last, for the project, also 0.25, which I'm going to multiply times 88. Here, let me write that down. Times 88. So I'm putting that in the calculator, and I get 22. So the total, let's add those together. So the 35.5 plus the 22 plus the 24, I get a total of 81.5. So what is your overall grade? Well, 81.5 is representing your total based on all of those. So your grade, and we're going to assume it's out of 100, would be an 81.5%, or probably a B based on a standard scale. Wow, can't talk. Based on a standard grading scale where 80-something% is usually a B. But there's your score. Okay, so here's the basic idea. To calculate your course grade, you take the weight of the first component times the score on the first component. In this case, our first component was tests. That's what we had first. Weight of the second component times the score on the second component. So that was the homework for us. And then the third component was the project. And is this what you did for question 3? And the answer is yes. We just used a table. Same basic idea. We just did it in a table instead. So now they're saying, imagine that you read the weights wrong in the syllabus, and this is the correct information. Tests are 25%, homework is 50%, and project is 25%. So let's correct the information. So let's see, that means that this is 0.5 and 0.25. Okay, so is this good news or bad news for you? Excuse me. That's good news because our homework is actually our best grade overall. We have a solid high A on the homework. So if it's weighted more, that means that it's going to bump our grade up. So it's good news. Grade is going to increase. And we might have a shot at an A. So that'd be my prediction. My prediction, maybe a low A. That's my prediction. Let's see. Let's calculate our grade using the updated information. So here, I'm going to actually just kind of do this off to the side, almost like create my own little column up here. Okay. So this is the multiplication of the weight times the grade. I'm just going to write W and G for no good reason, except for the words W, a weight for W and G for grade. So I'm going to grab my calculator and I'm just going to multiply in the calculator 0.25 times 71. And that's going to give me 17.75. Now I'm going to do 0.95 times 96, which gives me 48. And then that last category, 0.25 times 88, we actually already calculated that. That didn't change. That's just 22 still, same as it was for the first table. Okay, I'm going to add those all together. Here, I'm going to write that down here just because of space. If you have space to write it underneath, you are welcome to. So 22, 48, and 17.75 in my calculator. Oh, 87.75, or probably rounded would be 88%. Very close to an A. So, but a high B. All right, a high B. And it definitely brought the grade up quite a bit. Okay, another example of weighted mean is GPA. And it uses this idea of grade points. So an A is considered 4, which is why 4.0 is straight A's. A B is 3, a C is 2 points, and then 1 point for a D. And the weights are based on the credit hours. So when you have a high credit course and you get a high grade in it or a good grade in it, it actually weights more into your average because it took more time. You devoted more time to that class. Higher weighted courses tend to be considered more challenging classes, so you get more credit into your GPA. So here we go. They show how they calculate a GPA or how they calculate the grade points for this particular person. So they gave the credit hours for each of the classes and then the grade points based on the grade they earned. So they got an A in Math 98, which is 4 grade points, a C in writing 121, which is 4 credit hours. I'm sorry, 2 grade points for a C at 4 credit hours. And then for Art 101, they got a B. And they figured out the total grade points. And so to calculate the GPA, you divide that total grade points, this, by the total credit hours. And that gave a final GPA of 3.08. Okay, so let's try this on an example. Let's make a table. And let's find the GPA of a student who earned an A in Math 105, a C in Psych 101, and a C in History 101. Oh, and an A in PE 185. Okay, so let's go ahead and create the table just like they did. My table is not going to be perfect because I'm freehanding it. So here we go. Math 105, Psych 101, History 101, and PE 185. Okay, so the credits are 4 for math, 3 for psych, 4 for history, and 1 for PE. Okay, and then we are going to do the grade, and in particular, the grade points, how many points they get for each grade. I'll list the grade and then I'll do the number of points they get. So for math, they got an A. Awesome. So an A is worth 4 points. In psych, they got a C. A C is worth 2 points. History, a C also, another 2 points, and an A in PE for another 4 points. So what we're going to do is we're going to multiply the grade points times the credit hours, and that's what they're calling the total grade points. Points, which I'm abbreviating as PTS. So that's going to be 16 for the math 105. 3 times 2 is 6, 4 times 2 is 8, and 1 times 4 is 4. Okay, so we're going to total those. I'm kind of running out of space, but that's okay. So let's see, 16 plus 6 plus 8 plus 4, I get 34. And then the total credit hours I also need. So 4 plus 3 is 7, plus 5 is 12. Okay, so we're going to take 34, divide it by 12. Here, I'm going to do it in different color just so I can see it. 34 divided by 12 on my calculator. And I get 2.83 repeating. So I'll just put 2.83. They usually round GPAs to 2 decimal places. And there we go. Okay, so suppose a student already has a 3.74 GPA over 42 credit hours. She then takes 14 credit hours in a term and earns a 3.21 over those 14 credit hours. Let's find her new cumulative GPA. All right. So they kind of gave us a hint. They kind of said that when you look at the cumulative GPA, it is also a weighted mean. See how they say that right here? It's also a weighted mean. So we're going to take then the GPA earned for the beginning, the 42 credit hours, and times it by the 42 credits. So there's her GPA at that point for the 42 credits. Plus, she now has a 3.21 GPA for the 14 credits. So let's see what that gives us. 3.74 times 42 plus 3.21 times 14, which is a total of 202.02. But then we have to divide that by the total number of credits. So we're going to take that and I'm going to put it over the 42 and the 14. That makes up the total number of credits. So 42 plus 14 gives us 56. So 202.02 divided by 56. And my calculator for a new GPA of 3.61 if I'm rounding to 2 decimal places. Technically, I got 3.6075, but I'm going to round to the hundredths place. So 3.61 would be the new cumulative GPA.